This section examines engine bearings. No engine can run without bearings. Bearings are used in engines to support and protect rotating parts and allow them to turn freely. The connecting rod must be able to spin freely on the crankshaft. The crankshaft must be able to spin freely in the engine block. Connecting rod bearings and the crankshaft main bearings are called split sleeve types, which means that they're in two halves called inserts, slippers or shells. These precision inserts have a steel back with a very thin layer of bearing material bonded to it. The bearing material is an alloy that can include metals such as tin, lead, aluminium and copper. Bearings designed for light duty may be made of white metal. It's an alloy of tin and lead with small amounts of copper and antimony. Alloys of tin and aluminium improve the load carrying capacity for intermediate applications. Copper-lead alloys give even more improvements. They're used in applications such as diesel engines and high-performance vehicles. Bearings need a difficult mix of properties. They must be hard enough to resist wear, but soft enough not to damage the shaft. The soft bearing surface also allows any hard abrasive particles to become embedded in the surface. They can become so deeply embedded they're prevented from touching the rotating shaft by the film of oil. It's the mix of metals, tin, lead, copper and others, into an alloy that makes this combination of hardness and softness. In a main bearing, the upper half of the bearing fits into a machined section of a crankcase web. The lower half is carried in the bearing cap, which bolts onto the crankcase web. In a connecting rod bearing, its upper half is carried in the big end of the connecting rod. The lower half is in the connecting rod cap. One main bearing has thrust faces which accept the end movement of the crankshaft. These can be in the form of flanges that are part of the bearing. Alternatively, a separate thrust washer can be fitted into a machined recess in each side of the bearing cap. Sometimes a mating recess for each side is machined into the cylinder block and mating halves fitted to both. Under normal running conditions, spinning shafts ride on a microscopic wedge of oil. Oil flows through a long gallery in the cylinder block. Each main bearing has its own oil supply passageway from this gallery. Passageways drilled in the crankshaft carry oil from the main bearing journals to rod journals. Oil flow maintains the oil wedge between the shaft and bearing and carries away particles that could cause wear. Engine manufacturers specify the clearance required between the bearing material and the crankshaft. This clearance gives the best combination of oil pressure and flow. As clearance increases with wear, oil flow increases, causing oil pressure to drop. Then the shaft may rub against the bearing surface and wear even faster.